Also. Okay, so as Hugo introduced me, I'm Catalin Gheorghiu. I'm a solution architect from Romania. I'm working at a company that we are working with IoT even before the IoT had a name. I'm speaking at this event as the Intel Software Innovator. This is the title that Intel awarded me the last 2 years. Also from the year 2011, Microsoft each year awarded me the title of Most Valuable Professional, and I'm a current Microsoft Certified Trainer. So these are my credentials. So I'm going to talk to you about what we discovered when we try to apply computer vision to a real world project. Not let's say it's not that shiny and glossy like autonomous driving or something like this. It's a simple real world solution. The worker needs to put the right amount of screws and the right kind of screws, the right number of screws and the right kind of screws on something. And that was a problem because sometimes they forgot to put the screws and sometimes put the wrong screws. So the old world approach would be to put a weight counter and weight the screws and see what's up, and try to deduct from the weight of the screws if that's the right number. But this has several problems. You have only 15 minutes, and I'm not gonna delve into the problems. And we decided, okay, we are an IT company. We are always on the bleeding edge. If it's worth for our customers, let's look around. Computer vision was done, so we train the model and we use computer vision to ensure that the worker are putting the right kind of screws. But we are on the learning curve, so we took whatever is on the market and we try to compare what we have, if it can fit our do our task and do the stuff. For this, we have try to use a test rig, a very complex one, a Raspberry Pi with a camera. If you are trying to get a start with computer vision and we are trying to use Raspberry Pi, the recommendation is to use the camera from the Raspberry Pi, not faster and smarter cameras. Usually you get worse results. So, yeah, we try all this. Today we're going to talk about what we have discovered working with Intel. First, I'm gonna share you. Let's change. Talk a bit about terminology. So I'm gonna share my browser. It's a website we use. Let's to learn a bit, and also has very nice pictures. So what are the subjects that we have in computer vision? We have classification, localization, detection, and segmentation. Here are pretty well explain what it is. In our case, we needed to do detection and counting. So, okay, counting, you found libraries at GitHub. Also, it's below. These are the steps that you needed to follow to create a computer, an artificial intelligent machine learning solution. These are closer to a computer vision. First, you need to take the pictures, and then you need to use a tool to annotate images. Okay, this is usually the lab, or you can use from Microsoft. They have a computer vision. We like better that tool. And we need just on all the pictures that you have taken to say that this is a dog, this is a boat, this is whatever. Afterwards, you need to train this model. And here you are doing, you can also learn hardware on the cloud and stuff like this to do the training, and then deploy and use this model on the device. And then you have the prediction. So pretty much are the steps. What we have discovered from Intel. So stop share and share again the presentation. So share. So what they have something called OpenVINO. What's the problem they're trying to solve? There are a lot of deep learning frameworks, in the industry. Kafka, TensorFlow, Apache MXNet. They are a new one almost every day. So you need to adapt the code to this. Okay. And also, if you want to run the code on your own application, you need to do some code to do all this. I say, okay, we have a lot of hardware and there are a lot of models. Let's make this stuff easier. Let the user, train a model and get us the model, and we'll do the stuff, and you'll be able to run it on almost any device. Almost any device, they're meaning essentially from Intel. This means processor, GPU, programmable gates array, and also this stuff. So what OpenVINO doing? The principle is doing two stuff. Yeah, the first is the model optimizing. You're taking any model, any with very large margins, and it's let's say run through 3 steps. First, it's converted to intermediate representation. You got an IR file. This is basically 2 files. One XML file which describes the topology, the layers, and the conductivity, and the other one that describes the weights and the bias. And then takes this and optimize it in 3 steps. So the first step is at the network level. Operation that really do not map to the kernel, but to relationship between data. Second is memory optimization. Takes the data and put it better memory. And third, kernel level optimization. The Inference Engine will choose the right implementation. What do you mean by that? Usually the models are trained to a floating point 32 format. And sometimes to some hardware, this is an overkill. So it's not good. Maybe in a simple integer would be good. They say that this optimization are hardware agnostic. Yes, they are board agnostic, but not quite processor agnostic. Okay, afterwards you get the intermediate representation, and you get a simple API that you are running against this intermediate representation. This is not all. If you do not have a pre-trained model, they have also model zoo on which you can take a model just to try your stuff. And let's try a demo. We do not have that much time, and in the remaining time, I propose that we're gonna use this. I would say this is something you should look at. This is a neural processor. So we do not need to change the code. I modified an example from Intel, and just we need to run it. And modified it, I put a more stop share. Let's share. Let's see if I want to share everything. Okay, let's try it. I'm not power. Let's try to share this this demo. Here I'm just calling the demo, which I modified, and I said that I want to use it on neural stick, which I put in the PC, and I will click enter. Okay, you can call this Inference Engine from C++ and Python, so you are pretty much covered. On a downside, it's not that simple to plug it in from the very beginning. Here, when they got to the image, I'm gonna show you what they recognize. Okay, what's the problem with the model zoo in this particular case? It's trained with Chinese number plates, so they infer somehow that the number plate to be valid should be blue. But okay, you can train your model. Also, you can go and change the model zoo. Before Model Zoo was called Intel Math Kernel Library for Deep Neural Networks. and deep neural network library. So I believe that this is, no, we still did not see the picture, not even now. It's now saying that it's loading the device. And now I'm going to show you what's shown. Again, you should understand that like anything in artificial intelligence, you get percent. Here it's below a threshold. It shows that this is a black card, and this is the number. What I modify in this sample, it's to show more picture. Okay, my time is pretty much up. Let's say call to action. It's free to install. I believe the second version of OpenVINO for 2021. Downloaded it, try it. You have all these samples. You can modify pretty easy to put more cars or whatever, and look at it. And there is a good value proposition. And also, look at this. For some application, it's really worth the money. If you really compare, this inference was done at 30.1 CPS. If I was dying on my PC, which is an Intel i5, you get something like 2.5 CPS. So it's a huge increase in performance. It's worth the money. So pretty much this is all from me. My time is up. So thank you very much. I'll be here to answer questions.